Welcome to my channel Ganit Matrix. My mission is to help the engineering students to master the complex mathematics through clear step-by-step solutions. And if you are preparing for engineering mathematics courses for universities like JNTU, JNTUK, JNTUA and other competitive exams like IIT JEE, you are in the right place. Now I specialize in breaking down the difficult example problems into clear step-by-step solutions, so you can walk into your exams with total confidence. And this is change of variables from Cartesian to polar coordinate series, problem number 1. Evaluate the integral 0 to infinity a power minus of x square plus y square dx dy. Now the integrand f of xy equal to e power minus of x square plus y square represents a symmetric bell-shaped surface, and our limits are from 0 to infinity. So that means we are calculating the volume under the surface in the first quadrant, and this is the graph of this. Now to solve this, so we transform from Cartesian xy to polar coordinates r theta. How to that? We will use the substitutions: x equal to r cos theta, y equal to r sin theta, and dx dy equal to r dr d theta, x square plus y square equal to r square. Since our region in the first quadrant, how to find the r limits and theta limits? See this, and this is a region in polar coordinates. Since theta varies from 0 to pi by 2, since our region is in the first quadrant, so theta varies from 0 to pi by 2. Now how to find the r limits? Now draw the radius vector through the origin, originating from the origin through the region. Now identify where this radius vector enters the region and where this leaves the region. It enters at the origin and leaves at infinite. So that means r varies from 0 to infinite and theta varies from 0 to pi by 2. Now plug in these limits. Now if you see, if plug in the limits, r varies from 0 to infinity, theta varies from 0 to pi by 2. X square plus y square equal to r square, so this becomes e power minus r square. Dx dy, remember dx dy equal to r dr d theta. So finally this becomes e power minus r square, dx dy equal to r dr d theta. Now solve the inner integral first time. Solve the inner integral by substituting u equal to r square, that means differentiating with respect to r, du equal to 2r dr. That means we want r dr equal to 1 by 2 du. Now same thing, now we want the u limits. Substitute r equal to 0, then u equal to 0. Substitute r equal to infinity, then u equal to infinity. Now our u limits becomes integral 0 to infinity, right? E power r square is minus u and r dr is 1 by 2 du. So we take out the constant outside of the integration, we write 1 by 2 du, right? And integration of e power minus x is minus e power minus x, so this is minus e power minus u. After substituting the upper limit and lower limit, we will get 1 by 2. E power, if you substitute that, minus e power, substitute the upper limit, minus e power minus infinity, e power minus infinity is 1 by infinity 0, minus of minus plus, e power 0 is 1. So 1 by 2 into 1, so this is 1 by 2. Now substitute this 1 by 2 here and solve for the outer integral 0 to pi by 2 d theta. So integral 0 to pi by 2, our inner integral limit is 1 by 2 d theta. 1 by 2 constant, integral d theta is theta, substituting the upper limit pi by 2 into 1 by 2, which is pi by 4. Thank you.